is the value of k, given that you have k to the power of 6 equals 5 to the power of 6. And let's have it to be solution from here. So from here, we have, from here so far, when we have a to the power of m that equals b to the power of n. So far they have the same power. This implies that a equals b. So from here, we are going to have our k to be equals 5 to be the first solution. And so from here, k equals 5, not only solution for this problem. So let's check the other solution by taking k to the power of 6 minus 5 to the power of 6, then we set everything to be equal 0. So from here, we can simplify this as k to the power of 2 times 3 minus 5 to the power of 2 times 3. 2 times 3 will give us 6. Then we still have it to be equal 0. Recall that when we have a to the power of m times n equals as a to the power of m in parentheses to the power of n, and also equals as a to the power of n in parentheses to the power of m. So you can interchange the power. So now let us apply it here by having it to be k to the power of 3 in parentheses to the power of 2 minus 5 to the power of 3 in parentheses to the power of 2. Then let's put them to be equal 0. This is a perfect square. Before of this 2, recall that when we have a square minus b square equals as, open parenthesis, a plus b, we close it, multiply by a minus b. So applying it here, we are going to have our a to be equals k to the power of 3 and our b to be equals 5 to the power of 3. And so from here, we are going to have this to be k to the power of 3 plus 5 to the power of 3 in parentheses. When we apply this, then multiply by k to the power of 3 minus 5 to the power of 3, we close it, equals 0. Now for this expression to be equal 0, is either we have k to the power of 3 plus 5 to the power of 3 to be equal 0 from here, or we have k to the power of 3 minus 5 to the power of 3 to be equals 0. Now, having known this one, let's apply the sum of two cubes for this. Then let's put them to be case 1. Recall that when we have a to the power of 3 plus b to the power of 3, for this one equals as a plus b, then multiply by a square minus ab plus b square as this. So when we apply to this one, this will be our a will be equals k to the power of 3. Sorry, our a will be k. Then our b will be equals 5. So from here, we're going to have k plus 5 multiplied by k square minus 5k plus 5 square. Then we set it to be equal 0 from here. And so we have k plus 5 in parentheses multiplied by k square minus 5k plus 25. 5 square will give us 25, then equals 0. So now for this expression, it gets to be equal 0. It's either we have k plus 5 equals 0, or we have k square minus 5k plus 25 to be equals 0. Now from here, we have k to be equals minus 5. That is another second solution. Then from here, we can apply quadratic formula k to be equals minus b, positive or negative, roots of b square minus 4ac, then divided by 2a. Where we are going to have the parameter a, this a, to be the coefficient of k square, which is 1, then parameter b to be the coefficient of k, which is minus 5, and our c will be equals 25. So when we substitute everything here, we are going to have k. Already here is minus b, here is minus 5. So here will be 5, positive or negative, root of 5 square here will be 25, minus 4 times a is 1 times 25. 4 times 25 divided by 2 multiplied by 1. So we have k to be equals 5 positive or negative root of 25. Now when we have 25 times 4, 4 times 5 will give us 20, we have it to be 0. Then 4 times 2 will give us 8, plus this one will give us 10, here will be 100. Then divided by 2. So we have k to be equals 5 positive or negative. Then root of this will give us 25. Now 20 on 100 minus 25, here will be, that's 9, here will be 8. So here will now be 8 minus this one, here will be 75. So here will be 75, then divided by 2. So we can have 75 to be the product of 25 times 3. So 25 times 3, this will give us 75. We have k to be equals 5 positive or negative root of 25 multiplied by root of 3, all divided by 2. So we have k to be equals 5 positive or negative root of 25 is a perfect square. 5 square equals 25. So here will be 5 multiplied by root 3 divided by 2. So from here, we have this to be the complex solution. Sorry, we have this to be another solution. So here is minus, then here will be minus 3, here will be multiplied by root of minus 1. So where we are going to have k to be equals 5 positive or negative 5 root 3i, because root of minus 1 equals I in the complex place. So all divided by 2. So this are complex solution where we have the degree solution, the first one to be k equals minus 5. So from case 1. Then let's also check case 2 where we have k to the power of 3 minus 5 to the power of 3 equals 0. This will be our case 2. And recall that when we have a to the power of 3 minus b to the power of 3, always equals a minus b multiplied by a square plus ab plus b square, where we are going to have our a to be equals k, then our b to be equals 5. So from here, we are going to have it to be k minus 5 in parentheses multiplied by k square plus 5k, ab will be 5k plus 5 square will be, this one will be 5 square, then equals 0 from here. So now from here we have k minus 5 multiplied by k square plus 5k plus 25, then equals 0. Now for this expression to be equals 0, is either we have k minus 5 equals 0, or we have k square plus 5k plus 25 equals 0. Now from here, we have k to be equals 5. This is another solution. So recall that we can also get the possible value of k by introducing k to be equals minus b, positive or negative, root of b square minus 4ac, then all divided by 2a. So when we're going to have the parameter a, the coefficient of k square, which is 1, then parameter b, the coefficient of k, which is 5, then parameter c is 25. So from here, we are going to have k to be equals, here will be minus 5, positive or negative, roots of 5 square will be 25, 4 multiplied by a is 1, multiplied by c is 25, then all divided by 2. So we have k to be equals minus 5, positive or negative, root of 25 minus 4 times 25 will give us 100 divided by 2. We have k to be equals minus 5, positive or negative, root of 25 minus 100 will give us minus 25 divided by 2. We have k to be equals minus 5, positive or negative, root of 25 times 3 multiplied by root of minus 1. Recall that 25 can be written as perfect square of 5 to the power of 2. So we have k to be equals minus 5 positive or negative root of 5 square multiplied by root of 3 root of minus 1 equals I in complex space. So here will be multiplied by root I divided by 2. So we have k to be equals minus 5 positive or negative 5 multiplied by root 3I then divided by 2. This is another complex solution because of this, and we also have k to be equals 5. Recall from the other one we have k to be equals 5 positive or negative 5 multiplied by root 3I divided by 2. Then we also have k to be equals minus 5. So this is a complex, this is a complex, this is a resolution. So if you are new here and find this video interesting, don't forget to share, like, comments, and subscribe to our YouTube channel for more maths tutorial videos.